This is our fourth video for Unit 1, and we are going to cover some basic metric conversions and how we apply dimensional analysis to solve problems. Now, the math in dimensional analysis isn't necessarily difficult, but what I want you to get out of this is the problem-solving strategy that it allows us to have. So when we're looking at dimensional analysis, it's really using a series of conversion factors. So my example here is 1 foot equals 12 inches, okay? And let's say I have 36 inches that I want to convert to feet. I'm going to set it up in such a way that, first of all, since I have inches, on the next conversion factor, I'm going to put inches on the bottom and put 1 foot on top because foot is the unit I want to go into. And therefore, my inches, when I multiply these together, my inches cross out. So what I want you to notice, though, this conversion factor, if the top is equal to the bottom, it's kind of like multiplying by 1. So I'm not really losing the amount of 36 inches. All I'm doing, or I'm not changing it, I'm just changing the units. So that's the basis of dimensional analysis. Now there's some common conversion factors that I need you to know that we're going to use quite a bit in dimensional analysis, and most of them have to do with volume and water. So volume, 1 centimeter cubed, is equal to 1 milliliter. And 1 decimeter cubed, quite a bit bigger now, this is something, it's 1/10 of a meter, and it's three-dimensional, this is equal to 1 liter. Now, when we're talking about water here, if I had 1 milliliter of water, and most of you probably know this, you would have 1 gram of water. Now, that's not true with everything, that's just water, okay? And if I had 1 liter of water, then I would have 1 kilogram of water. Okay, so those are all conversion factors you just got to know. There are some other units that are involved here. There are 7 base units in the SI system, and they are meters for length, kilograms for mass, seconds for time, mole, which is probably one that people are less familiar with, but if you have an amount of a substance, it's a mole. And a mole is it's just a number. It's like a dozen. You know that a dozen is 12. Well, mole is just a bigger number, okay? And then we also have Kelvin for temperature. Now, there are 2 more. Like I said, there are 7, but these are the 5 I need you to know for chemistry. The other base units are candela, and that's for luminosity, and ampere for electrical current. Okay, but again, not needed as much in this class. There are prefixes that we can add to the base units that either increase or decrease the unit that we have, and these are all the ones that you're probably going to have to deal with in chemistry. Now, I put some base units down here at the bottom, but these are all of your metric conversions or your metric prefixes. I did put this on It's Learning. It's one of your resources in the folder, and there's also a Quizlet there if you want to use that to help study these prefixes. But I've listed it in such a way that they start at the smallest, this is to the -12th, all the way down to +12th. And I want you to kind of pay attention the way I have this set up here. 1 base unit is equal to this many nanometers, right? That's a lot of nanometers. And it's reversed down here at the bottom. It takes 10 base units to make 1 deca base unit, okay? Next up is some example problems. So I just want to show you just the basics on how to do some conversions here. And I put this actually on another piece or another document back here to kind of help me show you how to go about doing this. A little bit easier than doing it on the PowerPoint. So the example problem number 6 says that we want these converted into meters. So we're going to set it up like the conversion factor that we did on that previous slide. And because I have centimeters, I'm starting with centimeters, and I want meters, I'm going to put meters on top, and I'm going to put centimeters on the bottom. Now notice I'm putting the units in first, but now I've got to set them equal to each other. And if you check the metric prefix table that I have, you will see that 1 meter is equal to 100 centimeters. So I'm going to try and get this down here. 100 centimeters. Okay? And my centimeters will then cross out. And when I divide this by 100, I'm going to move over the decimal point 2 places. So I have 5.462 meters, because my centimeters are then going to cross out. Now, you don't have to use scientific notation for these, but you can. And I'm probably going to use scientific notation more than I don't. So I'll kind of mix it up here, and I'll do some with and some without, just so everybody can hopefully understand this. Okay, so my next one here, I'm also going to switch this to meters, to my base unit. So I'm going to multiply this by another conversion factor. And again, I'm going to fill in my units first. I know I want to get rid of kilometers, so I'm putting that on the bottom, and I want to go to meters. And I'm going to think to myself, okay, now which one is the larger unit? Is it meters or kilometers? And I know that kilometers is a larger unit, so I'm going to put a 1 next to that. And then I'm going to look on my chart and see how many meters equal a kilometer. And that is 1 times 10 to the third. Okay? All right, my kilometers will cross off or cross out, and I am left with 1.3 times 10 to the third meters. All right, next one up. We're going to set up our conversion factor. I'm going to put millimeters on the bottom because I want to get rid of those. I want to put meters on top. And I'm going to think to myself, which one is the larger unit? And whichever one it is, that's the one you put the 1 next to. 1 meter is larger than a millimeter. So I'm going to now look up my chart, and I'm going to see that it takes 1,000 millimeters to make 1 meter. Okay? And one thing to kind of point out here, what I want you to see is there is the smaller number next to the larger unit, and the larger number next to the smaller unit. That's how we always make sure they're always opposites. So hopefully that helps you to remember which number goes where, because that's probably the most common error when we look at these kind of conversions. Again, millimeters will cross out because they're opposite of each other, and I'm going to end up with 231.3 times 10 to the negative third. And you might be asking me, like, well, why is that a negative? Well, since this is on the bottom here, the 10 to the negative, or 10 to the third is on the bottom, I need to subtract that number. So my exponent ends up to the negative third. Now that's not a final answer, right? If we look at one of the previous videos, we know that the decimal point cannot stay there if it's scientific notation. I need to move that decimal point up to here, okay? And since I moved it up 2 places, then I need to change this by 2 places. I made this smaller. I'm going to have to make this larger. So this will be to the negative first meter. Okay, almost done. I've got 54 hectometers, and I'm going to convert that to meters. So I'm going to put meters on top. Hectometers, sorry about that, hectometers on the bottom. And 1 hectometer is larger than 1 meter. So I'm going to put a 1 down there, and it takes 100 meters in a hectometer. So I've got 54 times 100, so that's 5,400 meters. They're going to make me crazy. All right, last one. Okay, we're going to set up the conversion factor. I'm going to put meters on top and micrometers on the bottom. Now, micrometers are pretty tiny, and in fact, it takes 1,000,000 of them, 1 times 10 to the 6th micrometers, to make 1 meter. Okay, and that's going to give me 45612.21 times 10 to the negative 6th. Okay, and then of course we would have to fix this. We'd have to move the decimal point over all the way between the 4 and the 5, which means it's going over 1, 2, 3, 4 places. If that's going down 4 places, this must go up 4 places. So now I'm to the negative second meters. All right, I hope you have found this helpful. I will continue to do a couple more example problem videos, but please come see me if you have any issues. Okay, take care. See you later.